Hello everyone, you are welcome to today's lesson. In today's lesson, we are going to continue from where we left off on algebraic expressions, specifically word problems. Okay, in our previous lesson, if you remember, we looked at how to change word expressions, statements to symbols or algebraic expressions. Okay, so we mastered that in our previous lesson. We solved number problems in our previous lesson, how to deal with number problems. Okay, we were about looking at consecutive integer problems. Okay, you know integers or consecutive odd numbers. Odd numbers are also integers anyway. So let me generalize that consecutive integers. Okay, we were left with that then. Okay, time didn't allow us to deal with that. Okay, under the number problems. Okay, so integers are numbers basically. Okay, so we are going to start from there. Then after that, we'll look at age problems. Okay, so our target is to end at age problems today. So quickly, let's see, before I usher you into the consecutive integer, word example, problems word example, let's look at this. If you are dealing with integers, please, first of all, let's concentrate on positive integers. I want you to help me, the whole class, help me, list, the set of possible integers. At a point, maybe we know we cannot list all of them. Okay, at a point I will stop, then represent the rest by ellipses. So let's go, the whole class, unmute and let's go. Integers, positive integers for that matter. That's where our concentration is. Let's go. So integers, we are looking at one, I had one, 2, 3, 4, okay, 5, okay, maybe ellipses. It's enough for me to make my point. Integers. Okay, now, under the integers, we have another set of numbers, which will be even numbers. So let me deal with even numbers. Or I can say even integers is the same. Okay, even numbers, I usually don't write this. Okay, so even numbers, let's go. Even numbers will be 2, 4, 6, okay, 8, okay, 10, okay, ellipses. Okay, then odd numbers.
1,
okay, odd numbers will be what? 1, 3, 5, okay, 7, 9, okay, ellipses. Is that not it? Okay, very good. Now this is it. I'm just building your foundation. And when you get this, when you are looking at the consecutive integer problems, it will be very easy for you. So assuming I'm dealing with integers, and I say, represent my first integer by x. So first integer is equal to x. Okay, what will be the nature of my second integer if I'm dealing with consecutive integers? So my second integer, if my first integer is x, how do I get my second integer? Any suggestion, any ideas? If my first integer is x, okay, how would I get my second integer? Look at the pattern of the integers that we have there.
X plus 1.
X plus 1. Do you all agree, my professors? So you can see that your integers will be increasing by 1. So if you know the first one, the second one, you get it by adding 1. The third one, you add 1 to the second one and what have you. So it means my second integer, okay, let me use this, will be equal to x plus 1. What about my third integer?
X plus 2.
X plus 2, because it will be your second integer, then you add 1 again. So that will give us x plus 2. My professors, are you there?
Yes, please.
Do you agree? Are we all in agreement here? Any questions? If you don't get this, what we are going to do, okay, you will struggle because it will take its roots, okay, from here. Are we all fine, my professors?
Yes, please.
Okay, great. Okay, so now let's go and look at even numbers. So for even numbers, if my first even number, okay, is equal to x, what do you think my second even number will be? Let me use this to represent that. The even numbers, what will be the incremental jumps? What will be the differences?
2.
2.
2.
Do you agree? So if my first one is x, how do I get my second one? By adding 2. Is that not it?
Yes,
Yes.
sir.
Okay, all right. So that will give us what? X, okay, plus 2. What about the third integer?
X
Sorry,
plus
even
4.
number, not integer. Even number.
X plus 4.
You add 2 again to the first, so that will give you x plus 4. All correct, my professors.
Yes, sir.
Yes,
Okay,
please.
very good. Now let's come to the odd. So for the odd, my first, okay, odd number. If my first odd number, okay, is equal to x. For the odd two, what will be the differences, the incremental jumps?
2.
2. So if my first odd number is x, my second odd number, okay, will be equal to what? Again, x plus 2. Is that not it? And my
Yes.
third, just like the even numbers, okay, will give us what? X plus 4. All correct, my professors. My professors, are we all fine? Prof. Zoe,
Yes,
Marilyn,
please.
Frank, are we all fine? Okay, so if that's the case, then we are good to go. So let's quickly go and look at what our consecutive integer what problems. How to do that in terms of what our presentation. Okay, Prof. Giovanni.
So please can you go over the odd number? Well, I didn't get why it was x plus 4.
Okay, so you know that if you know one odd number, if you want to get the next odd number, okay, you add 2 to it because the difference is 4. So the difference is 2, forgive me. Okay, so if you pick 4 as your first even number, okay, if I want to get the next even number, I have to add what? 2 to get the next even number because the differences will be 2. You get it? So if my even number that I know is a general even number and I'm picking that as x, okay, then if I want to get my next even number, it will be x plus 2. If I want to get the next after the x plus 2, I will have to add, okay, 2 to the x plus 2. So that will give you x plus 4. So you keep on adding 2 to your previous, okay, terms to get your subsequent term. Is that not it? Your preceding term to get your next term. Is my point well made, Prof. Giovanni? Is it clear now?
Yes, please.
Okay, very good. Okay, so please do ask questions. I've told you, if you don't get it here, so don't shoot yourself, okay, in the foot. All right, so now let's go and look at what these, okay, questions. Okay, so question 2A, find two consecutive integers whose sum is what? Is 63. So we don't know the integers, but we know they are sum. Okay, so we are going to find them. So let's look at how best to carry out our presentation. So in this case, we are looking at two consecutive integers. So I am going to write, solution question number 2. I need to number first, so A. Okay, so in this case, I will let, okay, x be equal to my first, okay, integer. Do you agree? Because I'm dealing with integers. Is that clear?
Yes,
Professor,
please.
so this implies that if x is your first integer, then it means your second integer will be x plus what 1. Remember what we did. In terms of the integers, the incremental jumps will be 1. So my second integer will be what? X plus 1. Is that clear? Oh, first integer, I wrote integers. All right, forgive me. It wasn't intentional. Okay, so that's why sometimes when you write, you need to go over. So integer. All correct, at least up to this point.
Yes, please.
Okay, so now let's look at the condition that will help us generate the equation. We are told that these two integers, consecutive integers, their sum should give you what? 63. So it means the first integer, plus the second integer, when you add, you should get 63. Is that correct? Do you agree, my professors?
Yes, please.
Yes, sir.
Okay, so on that note, if I write but, I am told in the question that, okay, my first integer, which is x, plus my second integer, which is what? X plus 1. Let me change the first x. It's not looking pretty at all. Okay, all right. Okay, the second, okay, must be equal to what? 63. Okay, so at this point, you formed your equation in what? In, okay, x, and you are supposed to solve. So I'll write, this implies that if I add, I'll get 2x plus 1 is equal to 63. My professors, I hope you are following.
Yes, please.
Okay, so at this point,
Yes, please.
we are in a comfortable lead. Okay, so okay, we are going to get 2x to be equal to 63 minus 1. So that will give us 62. You write it again before you divide. So that will give you 62 here again over 2 over 2. So we'll get s to be equal to what? 31.
Yes, sir.
Okay, so you were asked to find the two consecutive integers. So we know one of the integers now, 31. Once you know one, because one is related to the other, you know the other. Okay, so in this case, what do we do? Okay, we are going to say that therefore, okay, we are drawing our conclusion. Okay, 31 and what? The other one will be 32. Okay, okay, are the integers. Afar, my professors, or the integers are, remember I've told you, it's better to write the math followed by, or you can write 31 and 32 equal to the integers. It's the same thing. My professors, is that clear? Is the explanation okay?
Yes, sir.
Okay,
Yes,
so
please.
now let's go and look at that of the B. Okay, so B, okay, two consecutive even integers. So this time round, your integers qualified with even. So you have to be careful. Okay, so the sum of two consecutive integers is 42. Find the numbers or find the integers, basically. So again, this time round, you know, you let, okay, x be equal to your first, okay, not integer, but even integer. Is that clear, my professors? Okay, so if x is the first even integer, then what do you think the second even integer will be?
X plus 2.
It will be, you know, in terms of the integers, the even, the increment will be 2, so it will be x plus 2. So that will be equal to what? Your second, okay, I can do this, but you cannot. You are supposed to write it in full, in exams or exercise or what have you. Is that clear, my professors?
Yes.
Yes, please.
Okay, so now again, let's look at the connection between the two, the relation. We are told that if you sum, okay, these two consecutive even integers, the result should give you 42. So it means x, okay, plus what? X plus 2, okay, should be equal to what? 42. Okay, so in this case, this implies that 2x, okay, plus 2 should be equal to what? 42. So you will get 2x to be equal to 42 minus 2, and that is what? 40. Oops. Are you following, my professors?
Yes, please.
Okay,
Yes,
very good.
please.
So that will give us what? 40. So on that note, we get 2x is equal to what? 40 again over 2 over 2. Okay, so you get your x to be equal to what? Okay, 20. So now you know the first integer. So your second integer will be what? Okay, s plus 2. So someone can also conclude this way. In this case, you will still get the two numbers. So someone can write, therefore, okay, first integer, first even integer, okay, is equal to your x, which is equal to what? 20. Okay, then second, okay, even integer. Remember, you cannot do this. Will be equal to what? X plus 2, which will be equal to what? Okay, 20 plus 2, which is equal to 22. Is that clear?
Yes, please.
Yes,
Okay,
please.
as simple as that. Okay, so I believe with that, you should be able to do the C. Okay, you know that when it comes to the consecutive, odd, and even, all of them you start with X for your first one, and the second will be X plus 2. You get it? So once your X that you find is odd, because automatically once you are asked to find odd numbers, the X that you find must be odd. And once you have your first odd number, the next one, if you add 2, you get the next odd. Okay, if you are looking for even, the numbers that you are finding, if you form your equation, your X that you find will be an even number. So if you add 2 to that even number, that will give you your next number, which will also be an even number. Is my point well made?
Yes, please.
Okay, so on that note, if I skip the C, okay, maybe give it to you as an assignment, okay, or you try on your own, okay, you would be able to do that, right?
Yes, please.
Okay, very good. All right, so if that's the case, then now, okay, so with this one, we are dealing with what? Three consecutive, okay, three consecutive odd integers. So as you read the question, we are going to underline. So odd. So this one, a little more bone. Okay, I will help you generate the equation. Then from there, I believe you can carry on. So odd integers. The critical information here is odd. Okay, we are told the sum of the last two is 15 less than 5 times the first. Okay, so hello, I think I've seen a message. Let me read. Oh, Caroline still can't join. How? Okay, so please let me pause and see. What is the problem? Is it not the same code that you use?
Yes.
So what is happening? Let me see. All right, so if you're able to do this question, any question at all on consecutive, okay, integer problem, be it odd or even or general integers, you should be able to deal with it. Okay, so let's look at how to break, okay, the question down. Every word problem, break it down. Okay, if you are able to break it down, you proceeding from there will be very, very what? Easy. So let's see, three consecutive, okay, odd integers. Okay, so we need to know our consecutive odd integers. Okay, so now you know how to do your representation. Okay, so we are going to look at how best we can carry out what? Our representation. My professors, are you there?
Yes, sir.
Yes,
Yes,
Okay,
sir.
please.
all right. So now let's see. So solution to question number 3. Oops. Okay, so we are dealing with 3. So let's, okay, our first integer be x, and I'm talking about odd integer. So first, okay, not just any integer, but odd integer. All correct, my professors.
Yes,
Yes,
please.
please.
Okay, so we are dealing with 3. Let me see. I've seen a message. Hey, Wilfred, be serious. Let your attention be here. All right. Okay, so this is what we have. Then this implies that if x is our first odd integer, then definitely x plus 2 will be the second, okay, odd integer. So you let me write it before you also develop that habit, or integer, and I expect it like that. Okay, so integer. Okay, then, okay, on that note, it also implies that the third integer will be x plus 4. Is that clear?
Yes, please.
So third odd what? Integer. Okay, so now we know. So we are going to use the second part of the statement, okay, to connect, okay, and give the equation. So we are told, I think, okay, this is not looking pretty, but at least you can see that is I mean integer. Later maybe I can effect the change. Okay, there. All right. Okay, so now this is what we have. Let's look at it. We are told that the sum of the last two is 15, less than the first, sorry, 5 times the first. The sum, okay, of the last two. So the last two will be this, is that not it? I hope you get it. The last two will be the s plus 2 and what? And the s plus 4. Do you agree?
Yes.
Okay, so we are told that the sum of these two, okay, is what? 15 less than 5 times the first. So let's see how best you are going to write your statement. Let me see. Send me how you write your statement via the Zoom. Do you get the point? Chat, direct message. Let me see where the hiccups will be, then it will help me carry out the explanation. Is my point well made?
Yes.
Yes,
Okay,
please.
all right. So let's see. You said indirectly, I've guided you. The sum of these two is supposed to be what? 15 less than 5 times the first. So 5 times the first will be 5x. So I want to know whether you know that it is 5x minus 15 or 15 minus what? Okay, so that's all that I want you to I want to know from you. If you're able to get that based on what we did the last time. Okay, so let's see. So the other part is what I'm looking for. Okay, so I'm waiting. Let me put it on pause so that when you give me, yeah, I'm waiting for your answers. Let's see what. So having gone through your various submissions, via the direct, message on what do you call the Zoom. I realize that we have one or two issues. So now let's see. This is what we are told. The challenge here, the major challenge that I saw from your presentation is what I'm looking at the second part of the statement. We know that the sum of these two should be equal to something, but that something is where the issue is. Now this is how I got it. Some of you wrote, 5x minus what? 15. Others also wrote 15 minus what? 5 fourths x. So let's see which was which based on the information that I've given you. So those of you who wrote 5x minus 15, walk me into your reasoning. You can put up your hand. Let's make the class interactive. You can put up your hand and you try to bring your case forward. My profs, I need you to talk now.
Mr. Akman.
Those of you who had the 5x minus 15, let me know why you think it's supposed to be 5x minus 15. And those who went for the second one to, will explain their answer. So I'm waiting. Oh, please hurry up. You gave me a certain answer. Just explain your answer. I know it's not by instinct. There was a certain reasoning behind your answer, and that's what I want you to walk us into. Professor Lekem.
Yes, sir. Sir, please, the question, it says the sum of the last two is 15 less than 5 times the first. So the first integer, the first odd integer over here is x. So 5 times that odd integer, so that's 5x. And then the sum of the last two is what? 15 less than it, so 5x minus 15.
I understand. So the way you have stated it, I understand perfectly, but I don't know whether the others equally understand. Please, anyway, that's your explanation. Let me see. Those of you who wrote the 15 minus 5x, do you have a change of mind or you still stick to it? If you stick to it, let me know where the issue is. or walk me into why it's supposed to be 15 minus 5x if you are sticking to what you have there. Okay, let me see. I know those. If you don't want to put up your hand, I will call you because your names and your answers are here. So I know those of you who wrote that. Let me see if I can, okay, fish one of you out. My professors, are you there? Okay,
Yes.
so I think you all agree that it's supposed to be what? 5x minus 15. Do you all agree?
Yes, sir.
Okay, so if that's the case, then I'm going to continue. I won't belabor the point. It's very clear because we said it is what 15 less than 5 times the first. So it will be 5 times the first minus 15. And the first is what we represented by x. As simple as that. So now you are going to write but. I'm told the sum of the last two, so I'll have the last two will be x plus 2 plus what? X plus 4. That's the sum of the last two, is what I have here. Must be equal to, I'm told, so you remember we said whenever you see x, okay, it represents equal to, remember what we did the last time. So it's equal to, he said 15 less than 5 times the first. So 5 times the first will be 5. The first is x and minus 15 less will be okay minus 15. Is that clear now?
Yes.
Okay, so now what do? We are going to get, this implies that, okay, if you combine this, we are going to get 2x plus what 6 here is equal to 5x, okay, minus 15. Okay, and you know you are solving for x. If you move this x here, it will be negative. I always want to avoid negative. So I'll rather move this one here and move this one here. So that I will get 5x minus 2x, which will give me a positive, okay, value. In my mind, okay, usually I will do it mentally. Though I'm moving to this side, I'll write it first. At this time, I'm going to stick to your usual way. So I'll bring this one here, which will give us 6 plus what? 15, and that will give us what? 21. Am I right? Okay, and that should be equal to 5x minus 2x, and that will give us 3x. Okay, you know it's not necessary to write 6 plus 15 is equal to 5x minus 2x. You can do that mentally. Okay, whenever you are adding, you are subtracting, that could be done mentally. So indirectly, I have my 3x is equal to 21. I write it again over 3 over 3. The fact that I've written the 3x here doesn't mean I moved. Okay, if A is equal to B, B is equal to A plus 4 that I use here. So x will be equal to
7.
7. My professors, I hope you are following.
Yes.
Prof. Marilyn Osetutu, are you there? Are you following? Prof. Marilyn, are you following? Are you there? Marilyn Osetutu. Prof. Zoe, are
Yes,
you following?
yes,
Prof. Zoe, are you there? Are you following? Prof. Frank.
Yes, sir.
Okay, Prof. Robert. Prof. Zoe, you've not responded. Are you there? Okay, all right. Prof. Wilfred, are you there?
Yes, sir.
Zoe, you are here, but you are not responding. Prof. Jaden, are you there?
There's noise in my background, so I need to turn it off.
Oh, okay, all right, that's okay. So then if there is noise at you, but then how then do you do proper concentration?
No, a phone was ringing.
Okay, all right, okay, so that's okay. All right. Okay, so now at least you could have typed. Okay, next time type. Okay, send me a message instead of maybe moving out of your place. You can send me a message. It's equally a response. Only that usually I want you to respond verbally. All right, so that's okay. So you know your x. So it means you know your first odd integer. So we are going to find okay the other what integers. Okay, remember you were asked to find the 3 integers. So I can indirectly write therefore. So let's conclude. Okay, I usually will find them and say that okay, the first integer is the integers are this and this and that. In this case, 3. Okay, so let me write, okay, the first integer, so first odd integer is equal to what? X, and that is equal to 7. Okay, second odd integer we said it will be S plus 2. So it will be S plus 2, which will be 7 plus 2, which is 9. Okay, then, okay, your third, okay, let me do this, okay, for lack of, so you cannot do this, I've told you already. And that will be S plus 4. So we are going to get S plus 4, and that will be equal to 9 plus 2, which is what, 11, or 7 plus 4, which is 11. Is that clear?
Yes, sir.
Okay, so let's see. Ordinarily, okay, if you do the right thing, you don't need to investigate. Okay, if you do the right thing. So let's investigate and see whether the condition is satisfied. Okay, so we said the sum of the the last two. So let's look at the sum of the last two. That would be 9 plus 11. What is that equal to? 20, right? Okay, and we said it should be equal to 5 times the first minus 15. So 5 times the first is 7 minus 15. Okay, so 5 times 7 is what?
35.
35 minus 15, that will give us 20. So you can see that what we've done, indeed, we are on the right track. They satisfy the condition there, the numbers that you have there. Afa,
Yes, please.
okay, very good. So now let's see. Okay, we are moving on to the age, okay, problem. Okay, but before we come to the age problem, are we all fine with the consecutive integer problems?
Yes, please.
We are all
Yes,
fine.
please.
Okay, we thank God. Okay, so now let's look at the age problem. Let me quickly, okay, look at the time. Let me see. Oops, okay, anyway, we should be able to finish. All right, on time. I thought maybe we wouldn't go beyond 1 hour for this, but it's worth it. You've made the class interactive and I like it. Okay, so now let's look at age problem. So I will take you through the basic information, how to appreciate the concept of age problem. Okay, and once you have this appreciation, we can now move on to, okay, deal with what worked example. Okay, typical exams questions. Okay, so now let's see. When you encounter an age problem, you will often see that the problem gives you the information about the age. I think I need to mute, okay, everyone, okay, before I am distracted again. All right. Okay, so the problem gives you the information about the age in the future or in the past, and you'll be asked to find the present age. So the information, it will be about the future age or the past what age, and you will be asked to use that to find, okay, the present what age. Usually that is how the question will be. So example, if a mother is 3 times as old as her daughter, okay, then their present ages can be represented as, so you don't know the mother's age, you don't know the daughter's age. And usually this is the advice. Because we want to avoid fractions, okay, this is what we do. We usually represent, okay, the one with the least age or the smaller age. I muted all of you. I don't know why the person has unmuted again. Let me see who the person is. Okay, all right. So I was saying that, okay, usually it is advisable to represent the smaller age by X so that you avoid, okay, what do you call it? Because the bigger age, or the bigger, or yes, the should I say the older person, okay, will have a bigger age. It's either you add a particular age or you multiply. So you avoid subtraction and what? And division. If you represent the smaller age, okay, by the variable. And in this case, you can see that between the mother and what? And the daughter, all other things being equal, the daughter's age will be smaller than the mother's age. Is that not it? Okay, I've not seen anywhere where the daughter, okay, is what older than what the mother. Okay, all right. So in this case, it means it's the daughter's age that will be represented by X. So if the daughter's age is what? Present age is X. Okay, take note. We are told that the mother is 3 times as old as the daughter. So it means the mother's age will be 3 times the daughter's. So that will give us 3X. Is my point well made here? We are building a point. So make sure you follow through from one point to the other. Is that clear, my professors? Are you fine?
Yes, sir.
Okay, now here, okay, we go. Okay, now if the problem gives you information about their ages, say 6 years from now, so it means here we are talking about future age. Okay, so then you can represent their future ages as. So once we say 6 years from now, obviously you know we are not talking about past age. We are talking about the future age. You get the point?
Yes, sir.
Okay, so if you are talking about the future age, then if the daughter's age is X now, present age is X now, then in 6 years' time, you know the daughter will be X plus 6. You add 6 to the daughter's age. Is that not it? The daughter's present age. Please, are you following my professors?
Yes, sir.
Okay,
Yes,
so
please.
once you add 6 to the daughter's present age to get the future age in 6 years, then obviously you know that the mother's present age is what? 3x. So the mother's future age in 6 years will also be 3x plus 6. So you add 6 years also to the mother's present age. Is that clear? So you add 6 years to their present ages to get their future ages. Is that clear? My
Yes,
professors,
sir.
Yes,
are you
please.
there? Very good. So that is it about how to create the future age, okay, situation. Now let's look at, so likewise, if the problem gives you information, okay, about their age, say 5 years ago, and anytime you see ago, we know that we are talking about what? Past age. Is my point well made?
Yes, sir.
Okay, so in that case, then we can represent their past ages as. So in future age, when you talk about the future age, we add the past age, you subtract. That is the basic, okay, information that you need to take note here. So 5 years ago, okay, if my present age is X, 5 years ago, it will be X minus 5. That is my past age 5 years ago. So if my present or age, okay, which is the mother's age, okay, is 3x, then the mother's past age 5 years ago will be 3x minus 5. Is that clear, my professors? So future we add, past we subtract, as simple as that. That is all that you need to know here. My professors, is that okay?
Yes, please.
Okay, so now if that is the case, then let's see how best we can make use of the information that we have just, okay, been subjected to. Okay, no, you now know, let's see how best we can what deal with it or use it in dealing with the following question. So first word example. A mother is 10 times as old as her daughter. In 20 years, she will be twice as old as her daughter. Find their ages. Okay, so when, okay, Prof. Nana Kwame.
So you said in 20 years, but it's written in 24 years.
Oh, I said in 20 years. I read 20 years. Oh, forgive me. 24. Okay, you don't go by what I said, you go by what is here. Is that okay?
Yes, sir.
Okay, so thank you. Okay, so that was just maybe an omission on my side. Okay, so you know, this is how we are going to deal with what? Our presentation. So we represent their present ages, okay, in terms of X. So first of all, solution, your question number is 1. So you will let X be equal to, is it the mother's age or the daughter's age based on the advice that you've been given? Which of the ages do you represent by X or must be represented by X? Prof. Dana Kwame Osafo.
Sir, please, the daughters each.
the daughter's age. So remember I said the advice is to go for, okay, the smaller. Okay, so the daughter's age. Very good. All right, so if that's the case, oops. Okay, so if that's the case, then it means I'll let S be equal to what? The daughter's age. So let me start by writing the daughter's age. So let me present it this way rather. Okay, so that you know that at least you can vary your representation. So I'll write okay, the daughter's age. So I'll write daughter's age be equal to X. Okay, so this will implies that the mother's age okay will be equal to, so we are told that the mother is 10 times as old, so it means it will be 10 times X. Is that clear? As the
Yes,
daughter.
please.
Okay, so that will be the present age or the present ages. Okay, in 24 years, are we talking about future or past?
Future.
Future. Okay, so future. So now we need to go and get their ages in 24 years before we can connect. Because the connection here is based on their ages in what? In 24 years. Okay, so we said in 24 years, I'm going to write in 24 years. Okay, comma. In 24 years, what will be the daughter's age?
X plus 24.
Very good. So the daughter's age will be equal to S plus 24. Please, do you agree, my professors?
Yes,
Yes,
please.
please.
Okay, very
Yes,
good.
sir.
So then if that's the case, then this implies that, okay, the mother's age in 24 years, okay, will also be
10x plus 24.
very good. 10S plus 24. You are doing well.
10x plus 24.
Very good. You are doing well. Okay, so it means the concept well, okay, taken. Okay, so I will bring the curtains down. You understand? So we are done with today's lesson. All right, okay, so let's continue. So at this point, we know, okay, their ages in what? In 24 years. But let's see the connection. Okay, in 24 years, let's see the connection. Okay, so the connection is that, okay, we are going to get what? We said she will be twice as old as her daughter. So in 24 years, okay, the mother's age will be twice the daughter's age. Do you agree?
Yes,
Should I
please.
come again, my professors?
Yes, please.
I should come again?
Yes, please.
Okay, so you know the connection here. Look at the relationship. The relationship that we have, that is the twice as old as her daughter. Okay, that relationship is connecting the ages in 24 years. Can you see that? Because he said in 24 years, this will be the relationship between the daughter's age and the mother's age. You get the point? So the
Yes,
mother's
sir.
age in 24 years will be twice the daughter's age in 24 years. That's the meaning. Proportion, do you get it now?
Yes, please.
Okay, so can I say that now I'm going to establish the relationship, but okay, I'm told that the mother's age, which is 10x plus or 24, okay, should be equal to, so remember we said is, okay, so it should be equal to twice the daughter's age, and that would be x plus what? 24, 2 times that. Is that clear?
Yes, please.
Okay, please, who wants me to come again? Okay, possible Augustine. Where exactly, what is the challenge? What's the challenge?
Sir, please, the 24 years part.
Okay, so in 20, so you are told that in 24 years, so your future age. Okay, so you know that in 24 years, if you are talking about in 24 years, as for this one, you understand how we got the S plus 24 and this, is that not it?
Yes, sir.
So I'm told that in 24 years, okay, so meaning, okay, the mother's age in 24 years will be twice, okay, the daughter's age in 24 years. That's why we said in 24 years, the she that you have there is referring to the mother. You agree?
Yes, sir.
Okay, she will be twice as old as her daughter. Remember when we said 10 times as old as the daughter, it was what? 10 times S. That's the present age. Is that not it? 10 times the present age. So
Yes,
what we
sir.
have here, the relationship here is for their future ages. So in 24 years, she will be twice as old as her daughter. So the ages that I'm connecting here will be the ages of the two in 24 years. So in 24 years, we've been able to determine their ages. So in 24 years, I know that the relationship is that the mother's age will be twice the daughter's age. So that by the daughter's age, 24 years. So it will be this, okay, time. So it will be equal to twice the daughter's age, because the daughter's age is what? Is X plus 24. That is the 24 years. You get it?
Yes, sir.
Yes,
Okay,
please.
sure.
Yes, sir. Yes.
Okay, very good. So at this point, once you form your equation, you are good to go. Okay, I remember I told you that I'll form the equation, then you move on. But let's do it together. This is the first example. So this implies that, okay, we are going to get what? 10x plus 24 will be equal to, we come and remove the bracket here. So we get 2x plus what? 48. Is that clear?
Yes, please.
Okay, so you are solving for x. So I'm going to write 10x minus 2x, that will give me 8x. Should be equal to 48 minus 24, and that will give us 24.
Yes, sir. Yes,
Okay,
please.
so 24. You write it again before you divide. Don't forget this. Okay, over 8 over 8. I'm solving for x. So x will be equal to, my professor,
3.
will be
3.
equal to 3. Okay, so you can see that now you know the daughter's age. You were asked to find their ages. So if you are finding their ages, is it not their present ages that you are looking for? So you are looking for the present ages, like I said. So in this case, okay, you'll be asked to find the present ages, given future ages, and what have your past ages. So I know that x is equal to what? 10. So the daughter's age, okay, will be 10. Don't forget, sorry, it will be 3 years. Okay, and the mother's age. So I'm going to draw my conclusion. So therefore, okay, I have room here, so I'm coming. What is happening to my, okay, digital board? Okay, so I think, okay, so I'll write therefore, okay, the daughter's age will be equal to x, which is equal to what? Okay, 3 years, or you can write the 3 years straight away. Okay, this is, yes, is universally accepted. Okay, so that's the, then what do we have? And, oops, my and didn't come. And, okay, the mother's age. You know will be equal to 3 times x. Is that not it? Is it 10? Oh, sorry,
Yes,
10 times
please.
x, not 3 times
Yes,
s.
please.
You were supposed to say no, please. All right, okay, so let's go. So that will give us what? 10 times x. Okay, so that will be 10 times what? Okay, 3. So that will be 30 years. So far.
Yes.
Okay, all right. So this will be it for the first question. I think we have, okay, more questions to look at. Okay, once your foundation is well grounded, then we go and look at what the, okay, so the solution to the class test. Okay, so now let's look at question 2. Jane is 6 years older than Grace. So between Jane and Grace, who is older?
Jane. Jane.
Jane. So it means when you are doing your representation, whose age should we represent by X? Ideally, whose age?
Jane.
Oh,
Grace.
the smaller
Grace.
age, oh, the smaller
Grace.
age.
Grace.
Grace, be
Grace.
careful,
Grace.
oh. Other than that, you are going to deal with subtraction or division. So if you represent Jane's age by X, then it means Grace's age will be X minus X. So you'll be dealing with subtraction. But if you represent Grace's age, which is a smaller age by X, then Jane's age will be X plus X. You get the point. So that's the difference. That doesn't mean you cannot represent Jane's age by X. You can. But we want to avoid subtraction and division. You get a point. Okay, so now what do we have? 2. Okay, so we are going to let Grace's age, okay, to be equal to what? X. So if the age of what Grace is X, then Jane's age, okay. Oh, I didn't write the age. That is wrong. You can't write let Grace's be equal to no. That is wrong. So let me clear that and do the needful. Where am I in a hurry to? Okay. So it's equal to X. So Grace's age, Jane's age, okay, will be equal to what? X plus. So do you agree? So these are their present ages. Okay, so now let's see whether the information that you are giving there to form the equation, okay, is about past, okay, future, or maybe their present ages. So if the sum of their ages is 32, here, have you mentioned any past age? Have you mentioned any future age here?
Oh, please.
No. Okay, so it
No.
means, okay, the connection that you have here is really for their present age. If the future ages, then we'll add if in 10 years' time or, okay, 5 years ago, then you see that the connection, okay, is talking about future or past ages. So take note. So I can say that in this case, I know the ages that I'm supposed to connect. So, but okay, I'm told that the sum of their ages should be 32. So meaning X plus what? X plus 6. Okay, which will be their ages. If I sum, I should get 32. All correct, my professors?
Yes,
Yes,
please.
please.
Okay, very good. So at this point, okay, we are okay in a good lead. So 2x plus 6 will be equal to what? 32. Okay, then you get 2x, okay, should be equal to 32 minus 6, and that will give us
13.
13 pa.
Please, wait. Sir, sorry. Wait, 32 minus 6, 86.
You divided. What did you do to get your
No,
30?
sir,
I'm
I've already
wondering.
gave the final answer. Sorry.
You gave the final answer. Okay, so that will give us what?
6.
Oh, no, I'm not talking about the final answer. 32
No,
minus
sir,
6.
26.
Okay, so 26. Okay, so you write it again before you divide. Okay, so you wanted us to know that you are done. Okay, anyway, you've gotten your point. Okay, so so x will be equal to 26, okay, divided by 2, and that will give us what? The 13 that you
13.
said. Okay, but you know, you cannot conclude with the x. Take note. In math, you avoid concluding, I've told you, concluding with what you introduced. So x has served its purpose. So in our conclusion, we shouldn't. Okay, so therefore, you were asked to find, okay, each one's age. So you are finding their ages. So I'll write, okay, Jane's age. Okay, or let me start with Grace. Okay, because that's the one with the smaller. So Grace, okay, age is equal to, or Grace is this years old. You can say that it's for 13 years. That is X. Okay, and okay, Jane's age will be equal to, we said that is what? X plus 6. So that will be 13 plus 6, and that will give us 19 years. All correct, my professors.
Yes, please.
Okay, as simple as that. Alpha, is everyone okay? My professor, is everyone okay?
Please.
Okay, so let's see if you can do, okay, one more. Okay, I think it was 12:30 to 1:30. Okay, so I think we can have, let's finish with this one. Let me see how many questions. So let's finish with this one. Then we come to, okay, maybe you go for your, what do you call it, water break. Okay. All right. Okay, so now let's see question 3. Okay, I'm going to pause. Okay, then you are all going to read the question, then form your equation for me. Just form your equation. Okay, maybe this plus this, okay, is equal to this times this, or this plus this. Form your equation and give me your equation. we'll all come back, okay, and look at the solution together. If you got the equation right, because the equation is the not. If you get the equation right, then it means you should be able to get the answers that we are looking for. Okay, so quickly let me pause, then ask you to do that. Let me see whether you'll be able to do that. Okay, so now, okay, we are back. Having read the question, okay, we can definitely see that this is different from the first two that we've handled. So I feel I have not given you enough information. Okay, you are not well equipped. You don't have the enough tools to deal with this. But that notwithstanding, okay, you should be able to do it anyway. Okay, so let's see. Let's build our argument together. Okay, so we are told the father's age is 34 years old. Okay, I mean, then the son's age. So you know their present ages. Okay, the other one, you can see that you were asked to find their present ages. Okay, using future age, your present, or what have you. Okay, in how many years will the father be twice as old as his son? So in this case, we are looking for the number of years that this condition will be satisfied. The father's age will be twice that of what the son's age. Now, professors, are we there?
Yes, please.
Okay,
Yes,
so
please.
in this case, okay, what is our unknown? Is the unknown an age or the number of what years?
Please, can you come again, sir?
Okay,
Yes.
so we need to get our representation. So are we going to say that let x be equal to, what will x or the unknown be equal to? That's my point. What you are
Sir,
looking
please,
for?
you are looking for
Number of years.
twice. Yes, number of years.
Number of years, as simple as that. Okay, I even guided you. So number of years, you all agree, right? Okay, so this time round, our parameter that we are going to introduce will be the number of years. So let's, okay, x be equal to, or number of years be equal to, okay, so that is the number of years. All correct, my professors?
Yes, please.
Okay, so now if that is the case, then we are going to say that we can see that the connection that we have here, okay, you can say that in how many years. So it means we are looking at the years that we don't know. So it's like in X years. Okay, you get it. The father will be twice as old as his son. So now what are we? In actual fact, we should have extracted the information here. Given father's age, 12 years, okay, son's age. Did I say 12 years? 34 years, son's age, 12 years. Okay, so we can do that. Is that not it? So let's extract it as such. Okay, so that's what I'm going to do. Let me quickly see if I can. Okay. Okay, so let me see if I can. I don't want to erase that, so let me see if I can just shift what we have there, move it a little down, then create room for, okay, the other representation. So let me move this one down. I don't want to erase and write it again. So let me move it down. Okay, then go and do the representation. Okay, other one. So given in this case, all right, so we should be good to go now. Okay, so that's okay. So I'll write, okay, given this time round, I'll start with given, okay, father's age. I hope you are following, my professors.
Yes,
Okay, what is the father's age? 34 years. Okay, and, okay, son's age. Okay, it's equal to what, 12 years, so you've extracted. All right. Okay. So now it's x that we don't the number of years that we don't know. So we let x be equal to the number of years. So if that is the case, then we are going to write this means in x years, comma. Okay, what will be the father's age? Okay, or let's start with the son's age. You remember, okay, it doesn't really matter. This one you didn't represent, okay, their current ages by x or what have you. So in x years, let's go by the father's age will be father's age will be equal to what?
Daddy.
Hey, Portia, let your attention be here. All right.
Sorry.
In X years, what will be the father's age?
Yes, ma'am.
It will be, the father's present age is 34. So in the future age, okay, what will be the father's age?
X plus 34.
Okay, so it will be 34 plus S or S plus 34. Please, do you agree?
Yes.
Yes, please.
Okay, so 34. So this implies that the son's age will equally be the present age, which is the 12 years, then plus the X. All correct.
Yes, please.
Okay, so
Yes.
this will be the two that we are going to connect. So we are told that in X years, okay, the father's age will be twice that of his son's what age. So it means the father's age, which is 34 plus X, should be equal to twice the son's age, which is 12 plus X. Is that okay?
Yes, please.
Okay, so now I'm going to write, but I'm going to form the relation. Okay, knowing now that I know the ages that I'm supposed to connect. So, but the father's age, which is 34 plus X, should be equal to twice the son's age. So it will be 2 times what the son's age is a 2-term age. So you put it in brackets. So in this case, we are going to get, this implies that 34 plus X will be equal to, you come and expand. So you get 24 plus 2X. All correct, my professors?
Yes, please.
Yes,
Okay,
please.
so we are good to go. Once you form your right equation, which is this one, okay, you are more than good to go. It's a simple linear equation which we should all be able to solve. Okay, so now what do? We are going to solve and we are going to get what? We'll move, if you move this one, this X here to this side, you get negative. So you end up dividing by negative. I always want to avoid that. So I would rather move this one to the side. So, and bring this one here. So I'm going to get what? 34 minus 24, and that will give me 10. That should be equal to 2X minus X. That will give me X. Is that clear?
Yes, please.
Okay,
Yes, please.
so you can see that because I moved in this direction, okay, and I had a positive X, I don't have another step. If you had negative, then you are supposed to write it again and divide by -1. So that would be, okay, one more step. So that's the more reason I always want you to avoid dealing with what a movement that will result in the quantity that you are looking for being negative so that you divide. So someone who didn't do this will have, okay, 1 or 2 steps before getting the answer. So in this case, we know that our X, which is the number of years, will be 10. So you don't write therefore X equal to 10. Remember, X came by way of your own introduction. You are not giving X directly. If X was given directly, then you can conclude with X. So in this case, once you know X has served its purpose. So therefore, okay, we said X will be the number of years. So how do we conclude? So therefore, the number of years will be what? Will be, okay, 10. Or therefore, in 10 years, okay, time. Therefore, in, okay, 10 years, okay, time. Or the number of years is what? 10. How many years? So you are looking for the number of years. Is that clear?
Yes, please.
Okay, so as simple as that. Okay, professors, all well understood?
Yes.
Oh,
Okay,
well.
Yes.
okay, we thank God.
Yes, please.
Okay, all right. Okay, so I guess, okay, those who were struggling to, I just saw your messages, you've been able to join. We thank God. All right. Okay, so at this point, we are going for our water break. I'm expecting, okay, so let's see. Okay, what says the time? Let me see there. Okay, so let me pause quickly when you come. So I think those of you who want to try this, you can try, okay, this, okay, whilst we are on water break. Okay, so let's see. Okay, so welcome back from the water break. Okay, so this question 4 will be yours. Most likely, I'll put it on the class page as your assignment. Okay, so take note. You should be able to do this because it's similar to what we have done. Okay, so now let's move on to the next one. Okay. Okay, a woman is twice as old as her daughter 20 years ago. So let's deal with what the past ages, okay, question. So far, I think we have dealt with the present, okay, age relation and future age relations. We haven't dealt with past age relations. So let's do one of that. Then I think the others you should be able to, okay, deal with it. Okay, so quickly, this is what we have. Okay, so as usual, we know how we are supposed to proceed. Let's appreciate the question first. A woman is twice as old as her daughter, so their present ages we don't know. Okay, but we know the connection. Okay, 20 years ago, so that was past age. She was 4 times as old as her daughter. So this one is very, very easy. So you know the connection that we have here is about their future ages. The second connection that we use is setting up our equation. So question 5. Okay, what do? We let, okay, between the woman and the daughter, obviously you know the daughter will be younger. So what do? Is that one that we represent by X. So I'm going to represent the daughter's age, or we are to represent the daughter's age again. Be equal to the daughter's age is what? X. So this implies that if the daughter's age, and please don't come and write, let me say this here. Don't write let again. Okay, after if the X is what? The daughter's age, then it implies, it's not let, it implies that a woman's age, in this case, the woman's age, okay, will be equal to him. What will be the woman's age?
Say 6x plus 9.
Oh, are you sure?
Sir, please, do you want the woman's
Oh, we
age
are looking
now?
at, we've started. So look at where we are and give me the answers to the question that I'm asking. Okay,
2x.
Prof. Frank.
Sir,
Please, 4x.
It will be,
4x.
oh, look at the first statement. We are using the
2x.
first statement. The present age, we've not come to the years ago. That's the more we do.
2x.
It will be 2x. Prof. Frank, do you get it?
Please, 2x.
2x. So don't be in a
Yes,
hurry.
please.
Just look at what we are doing and let's build our argument. So that will be 2x. So you can see that if I'm talking about future age, past age, usually I will come and write in whatever. So in this case, I have 20 years ago. So I'll come and write 20 years ago. Okay, so it means now the relationship that I'm going to write here will be in terms of their ages 20 years ago. Okay, so these are the present ages. 20 years ago, what will be the daughter's age? Or what was the daughter's age, I should say?
4x.
Hey,
X plus 20.
it will be, no, are you sure? Ago.
X minus 20.
Please, you see, some of these mistakes, you know, I've told you when you see ago, it will be subtraction. When you see in, that's the future, it will be addition. And you are saying plus. Meanwhile, it's ago. You get it? So don't just talk, don't just write. So in this case, the daughter's age, the present age is X. So 20 years ago, it will be X minus 20. Point well made.
Yes, please.
Okay, all right. So now we come to, so this implies that, okay, the mother's age also 20 years ago, because it's under 20 years ago, okay, will be equal to, it will be the current age, which is 2x, also minus 20. Is that clear?
Yes, please.
Okay, so now you can see that the connection that we have here, we said in 20 years ago. Portia, let your attention be here.
Sir, please, what did I do?
You were singing, were you not the one singing?
No, it wasn't me.
It was the radio. Who was singing? Please, if you need a producer, just send me a message back door, okay? Okay, so the person singing, all right. Okay, so let's see. This is what we have. Okay, so we said 20 years ago, she was 4 times as old as her daughter. So it means the connection that we have here, okay, is for their ages 20 years ago. So I need to generate their ages 20 years ago before I can connect them. So we have done that. So we are now going to connect them. So where we are connecting, that's where we write the but. My professors, I hope you are following.
Yes, please.
Okay, so but we are told that 20 years ago, she, and the she here is referring to the woman. So the woman's age, which is what, 2x minus 20, we said is what? Okay, is what? 4 times as old as her daughter. So it will be 4 times, okay, the daughter's age here, which is what? X minus what? 20. Is that clear?
Yes, please.
Professors, any questions here? If you are not able to get this, okay, equation right, everything, remember, will be wasted effort and time. All correct?
Yes, please.
Okay, so now we are in a pole position to find, okay, we said how old are they now? So we are looking for the two of them, their ages. Sometimes the question could be, how old, okay, is the daughter? So in that case, when you find the X, you conclude with that. Don't go and find the woman's age. Or how old is the woman? Okay, so you conclude only with the woman's age. Okay, so in this case, we are asked to find both. So we are going to write 2x minus 20 should be equal to 4x, okay, minus what? 80. Am I right?
Yes, please.
Okay, so on that note, if you continue and solve, you should know the answer that you are supposed to get. Okay, so should we solve everything together, or I should just give you the answer? Let me see if I can. Okay, so maybe if you solve for x, I'm going to skip. Okay, I'm doing that mentally. If you solve for x, you are going to get x to be equal to, so you continue
30.
here, x will be equal to what, 30.
Yes, please.
Okay, I did that mentally. That's what I, so it means I was right. So in this case, it will be therefore, okay, so the daughter's age.
10.
Hey, 10 album. Or you were talking to someone.
Sir, please, sorry.
It cannot be 10. Okay, it's supposed to
Okay.
be, okay, 30. So the daughter's age will be 30 years. Do you agree? Because that's what you represented by X. And the woman's age.
My name is Sheila.
Okay, Godfred, or say I think you've been caught this time round. Okay, so please, okay, I've told you if you need a producer, just okay, send me a WhatsApp message. Okay, so either I produce you because we all know you have a nice voice, or I'll look for one for you. All right. So this will be the woman's age will be equal to, we said it will be 2 times X. So that will be 60 years. 2 times 30, so that will be 60 years. Is that correct?
Yes, please.
Okay, very good. So on that note, okay, I think this one will also, okay, be yours. Okay, this is what will separate the boys, okay, from the girls, or the boys from, or the men, okay, or the girls from the women. So that's it. So you will equally add this one to your, okay, and this as well. Let me see. Okay, Sam's age is 18, Bill's is 24. In how many years? So this one is also talking about you are looking for a certain number of years, but that one is a goal. So let me see whether you can do this. So I think I will use this as a yardstick to do something which I should have done before this meeting. Okay, but so on that note, I think the questions you read, I will put them together as your assignment just to help me do something in the very near future. Okay, so on this note, I would want to say thank you very much, okay, for a wonderful class, a wonderful lesson. I'm most grateful for your contribution and for your time with me. Okay, God bless us all.